Great. And so what that is you are going to have one job. So one task overall. So that's what we're going to call this. One job. And then that is going to be completed by multiple people in a certain amount of time. So in example 1, Yasmin can paint a fence in 8 hours. Jeanette can do it in 4 hours. How long will it take for them if they work together? So basically, I want to take their rate at which they work and combine them together. So I'm going to have 1/8 plus 1/4, because 8 is going to be representative for Yasmin. 4 is going to be representative for Jeanette. And then we want to see if we are combining their two rates together, how long does it take them to do this job? So 1/t. We don't necessarily know what t is, but we can use what we've learned about rationals and fractions and adding and subtracting to be able to solve. So the first thing you have to do is you have to find a common denominator. So between 8, 4, and t, my least common denominator, any guesses what it would be between those three things? 8, 4, t. I need a least common denominator where they all look the same.
32t.
32t is the closest I've heard.
16t.
16t is closer.
8, isn't it 8?
8t is going to be the least common denominator. 32t would also work. 16t would also work. Remember, you're trying to see what can I multiply these by so that they all look alike. And so for the 8, I can go in and I can add a t on the top, a t on the bottom, and that's going to make 8t. For the 1/4, I can add a 2t on the top, 2t on the bottom. That's going to make an 8t. And then I can add an 8 and an 8. Now, if you were someone who went to 16t or to 32t, that would be fine. You would just have a little bit bigger of numbers that you're working with, which should not be an issue because you would have a calculator. But sometimes it's easier to just take the least common denominator versus introducing a lot of bigger numbers. Okay, now that we have the same common denominator, we can come in, and it's not going to be a huge deal for this type of problem, but we can say our undefined value is t cannot equal to 0, which makes sense. They're not going to do it in 0 amount of time. But now that I have that, I'm going to come in and cancel out my denominators. So 8t is going to cancel out all of these denominators here. So we're basically solving a rational equation. So now that I have my denominators canceled, I am going to simplify my numerators. So t plus 2t equals 8. And all I did was get this from my numerators. That's all it came from. So we combine like terms. I'm going to get 3t is equal to 8. If I want to get 8 by itself, I'm going to get t is equal to 8/3. Now, this is asking how long will it take for them to complete this job together. So if I want them to complete the job together, I don't say it takes them 8/3. We have to convert this to hours and to minutes. So how many times does 3 go into 8? Twice. So this is going to be 2, and it doesn't go in perfectly because I would have 2 times 3 is 6. So it leaves me with 2/3 left over. Now, when we convert this to hours and minutes, it's going to be 2 hours. How many minutes are in an hour? 60. So how many minutes is 2/3 of an hour?
45. Oh my God.
Close, but not quite.
That's actually bad.
40 minutes. Now, if you did not know, because not everyone knows how or where that came from or can even tell time on a regular clock, we can take 60 minutes times 2/3. Remember, you are going to have a calculator. You can plug this in. This is what would give us the 40. 2 hours, 40 minutes. Zite, did you have a question or did I answer your question?
I think you did 8 instead of 8t because you did 8t would be 8.
What?
It would be different.
I want to get t by itself, so I would have to divide both sides by 3. I can't divide both sides by 8.
No, on the top, like the very first thing we did, you multiply by 8 at the very end instead of 8t because
It has to have a common denominator, so it needs the 8. Yep. Okay, let's go to the next one. So it says Tim can stuff envelopes 3 times as fast as his wife Jen. They have to stuff 5,000 envelopes for a fundraiser. Really quickly here, a big mistake that people make, even though they have 5,000 envelopes, a lot of people want to change the numerator to be 5,000. The numerator in this case is still going to be 1 because it's one job overall. Now, for a fundraiser, working together, Tim and Jen can complete the job in 4 hours. So this problem is set up a little bit differently. How long will it take each of them if they were working alone? Christian, Site, Wyatt. Okay, so how long will it take them if they're working alone? Now, here's where it gets to be a little bit confusing. We kind of know that they're going to complete one job. So one job over something plus one job over something equals, we know together it's going to take them 4 hours. Now, again, it's 1 because it's one job. You're not going to put 5,000 or ever change the numerator. It's always 1. So 1 over 4 is what they can do together. So we have to kind of figure out what their individual rates would be. And where that's going to come from is it says, with the Tim can stuff 3 times as fast as Jen. Now here's where a lot of people mess up. If I kind of put this into a chart, Tim, Jen. If it takes Tim, let's say 5 hours, and he does it 3 times as fast. So how long would it take Jen if he does it in 5 hours? 15. Because he does it 3 times faster. Okay, so what if he did it in 10 hours? How long did it take Jen? 30, because she's 3 times as slow as he is. Okay, let's put it into a variable. If Tim is X, what is Jen? 3X, because what is, if I think formula-wise, if I want the left side to be equal to the right side, 3X. 3 times as long. I was letting some people process. So
It was unexpected.
with the Tim, he is going to be our X. Jen is going to be our 3X. Now, looking at my 3 denominators, X, 3X, 4, what is my least common denominator? 12X. Because they all need to be the same, and they all have to be multiplied by something to get them to that number. So I'm going to do 12 on the first fraction, 12 on the second, 4, and then I'm going to do 3x here. Because that is what's going to cause all of these denominators to get multiplied to be 12x. So now we're going to simplify. I'm going to, again, first kind of identify my undefined values. These usually aren't going to be a huge problem. For the most part on your test, we don't necessarily run into any issues because usually it's 0. I'm going to go in, I'm going to cancel out my denominators. What is my LCD? 12x. So if I set that equal to 0, x cannot be equal to 0. Okay, canceled out my denominators, and then I'm going to be left with my numerators. So 12 plus 4 is equal to 3x. 16 is equal to 3x. So x is equal to 16 over 3. Now, you will have to convert these to minutes and hours. So how many times does 3 go into 16? 5 times. With 1 left over. So if I have 1/3 of an hour, how many minutes is that?
20 minutes.
20 minutes, right? Because 2/3 is 40, 1/3 is 20. Now that is going to represent Tim, because we said Tim is going to be X. So Tim is going to take 5 hours, 20 minutes. But that is not the entire question. It says how long would it take each of them to do this individually? So what do I have to do to Tim's time to find out what Jen did? Multiply it by 3. So I'm going to come in and I'm going to have for Jen, and Jen's having a real rough time because it's going to take her 16 hours to do it by herself.
How long does it take to do it together?
4 hours.
She don't even know.
She's working real slow. She's working real slow.
She's a young girl.
Jen took 16 hours. Okay, now on your quiz on Thursday, there will be one of these types of problems. It can either look like number 1 or it can look like number 2. It is one of these types. That is one of the questions. Now, the second type of problem you can encounter is an averages problem. So a college basketball player has made 58 out of 82 attempted free throws. How many additional free throws must she make in a row with no misses to raise her free throw percentage to 80? So we're kind of starting off with 58 out of 82. And then we want to get to 80 over 100 because 80% is 80 over 100. Now, what we have to think about is she is going to add to the shots that she made. So that means we're going to add a number to the numerator. But every single time you add a number to the numerator, you also have to remember that you are adding to the total attempts. So that same number is getting added to the denominator. So every single time you set up a problem like this, you are going to add a value, but don't just add it to the numerator. You also add it to the denominator. Yes, Christian?
I'm confused why we're adding the value.
So we're trying to increase her free throw percentage from where she started, the 58 over 82, to 80%, because that is not 80% yet. So she has to make more free throws in order to raise it up to 80%. So that's why we're adding values. Okay, now, easy peasy from here. We are going to get a common denominator and we're going to solve. So I'm going to go in and I'm going to say my LCD. Now, these do not look anything alike. So that means that they both have to be a part of my common denominator. So I'm going to have 100 and I'm going to have 82 plus x. Technically, I can say 82 plus x cannot equal to 0. So x cannot equal to negative 82. That's an undefined value, but we're not going to say that she's missing anything, so we're not going to have a negative value. But that would be technically my undefined value. So now that I know my LCD, because they don't look alike, so I just have to use both of them. Now that I know what it is, I need to go in and give the missing pieces. So I'm going to give a 100 to the left side. I'm going to give 82 plus x to the right side. And then once they have the common denominator, now that we know what the LCD is and the undefined value is, we can just come in and cancel out those denominators. Now, this is where you would probably find yourself using the calculator a little bit more. I'm going to go ahead and show you the multiplication. Remember, on your quiz, we will have a 4-function calculator for you built into the quiz. So it will kind of pop up on your screen. So I'm going to have 5,800 plus 100x equals 6,560 plus 80x. And all I did was distribute my 100 and distribute my 80. That's all that's coming from in the numerators. You're going to want to get your x terms on one side and your number terms on the other. So I'm going to subtract 80x, and then I'm going to subtract 5,800. And so we should end up with 20x equals to 760. And again, don't think that the numbers are too big and you can't do it. You will have a calculator for something like this. And then we go in and we get x is equal to 38. Yes, Christian.
If we simplify before we subtracted, will you get the same answer?
What do you mean by simplified before you subtracted?
Like, yeah. By like, so like divided all of everything by.
Oh, yeah. That should be the same thing. 38 free throws. Now, one of the things about word problems is typically there's going to be a point allotted to do you have units. So make sure that you're including units in your answers whenever you start these problems or in these problems.
Why is the plus x not equal to
What do you mean?
Because at the top, we added some of that.
That's just a part of the original equation that we added in to set it up. Not the plus x being like multiplied on top and bottom.
So that's in the equation.
That's in the equation.
Where is that in the equation?
Which one?
Plus x, you added them together, so 50.
That's a part of like the setup of it. So that's a part of the equation setup that you do before you change anything.
What?
That's like the setup. That's not where adding it in to create a common denominator. That's a part of the setup. Hi, Alex.
Hi. I thought Miss Khan had a class this period because I observed.
Uh-huh.
Can I observe her
Yeah,
class?
you're fine.
'Cause I thought she had a period.
Yeah, you're fine. So there, it's because of like the setup of the problem, not because we added it in as a like LCD. Okay, let's go to the back. I will tell you, the back ones are the more challenging ones. This is going to require distance, rate, and time. So when we go on, we are going to have the formula that distance is equal to rate times time. One of the things that you have to recognize, if I want to get time by itself, I'm going to go in and I'm going to divide both sides by rate. And so that's where this T is equal to D over R is coming from. Now, with this, we normally kind of set up a table to organize all of the things that we're going to have because they're going to give you a lot of information. So it's talking about jogging, and I have a question, a general question. If I am jogging downhill, am I going faster than I normally would, or am I going slower than I normally would? Faster. If I'm jogging uphill, am I going faster than I normally would, or slower? A little bit slower, right? So that is going to have a big effect on how we write these equations. So when we do this, it's typically going to be like your original speed with no like added anything. Just I can run 3 miles an hour. Now, in that case, we're going to add or subtract anything extra. So if you are going downhill, you may have an added speed. If you are going uphill, you may have a subtracted speed. But that is going to be like the extra stuff that gets added on to what you would normally do originally. So in example 4, Jesus can jog 5 miles downhill in the same time it takes him to jog 3 miles uphill. He jogs downhill 4 miles faster than he jogs uphill. Find his jogging rate each way. So I'm going to come in and I'm going to set up a table. Distance, rate, time. Distance, rate, and time. Now, there are 2 directions that he is going. He is either going uphill or he is going downhill. Now, with this kind of setup, we know his kind of increasing speed. So he can jog 5 miles downhill. So I'm going to put the distance with the downhill as 5. Because that's what they're saying. In the same time, it takes him to jog 3 miles uphill. So this is why the table's nice, because it kind of helps you organize some of your information. Now, it also says he jogs downhill 4 miles per hour faster than he jogs uphill. So is the 4 miles per hour faster his original speed, or is it the something extra? It's the something extra. So when I write this, it's saying downhill. I'm going to write this as x plus 4. And his regular speed is just going to be what we consider his downhill speed. Because you can also write this in two different ways. You can write it like what I have, or you can make x the uphill speed and x minus 4 the downhill speed. So it kind of just goes in both directions. Or hold on, wait. I switched it up. Downhill, let's put it on the bottom. Put it in the wrong spot. This is x plus 4. Sounds like a personal problem.
He's playing with this.
X plus 4. Okay, now, time. T1, T2. So what you're going to do is you're going to set up T1 as distance over rate. So this is going to be 3 over x, and T2 is going to be 5 over x plus 4. So all I did was use this formula here. T is equal to D over R. Now, in the question, one important phrase that they include is he can jog 5 miles downhill in the same time as it takes him to jog 3 miles uphill. So when it's a same time question, you are setting these two things equal to each other. So I'm going to have 3 over x is equal to 5 over x plus 4. Because it's going to happen in the same time. Now, what is my least common denominator? X plus 4 and x. Both of those things have to be there. So my LCD is x plus 4. So I want you to try and solve for x. Yes, Christian.
The undefined values matter.
They're not necessarily going to be things that you get, because if I go in and do this, x cannot be equal to 0, x cannot be equal to -4, which you can't have a negative speed or a 0 speed, so that should make sense. So try solving this. I'm going to come around. I'm going to see, let me double check my answer, that if we're getting the same thing.
Wait, so when I get x, do I plug it back into the equation?
DJ, stop.
Ask the question when she get around here.
Stop.
Get your least common denominator, cancel out your denominators. I'm seeing a couple people who are already there.
Me, miss.
It is asking the question of what is his jogging rate each way. So you should have technically 2 answers.
She gonna skip me.
What's your question? What does the x plus 6 represent? Look at your table. It's like what versus like uphill versus downhill speed. Oh shoot, I did it wrong. Uphill speed, right? And then we're going to go in and find his downhill.
So I plug in x
Back into what? So what is his other speed? That's one of the answers.
Oh my god, I get 6.
I don't know what that is.
How do we figure that out, you know?
Can you tell us?
Oh no, I should just told you.
What did she say?
Quiz on Wednesday. No, Thursday.
Oh, when I'm up the speed. Do you hear that? Okay, you get this,
You're slow, dude. You're slow.
I'm against this.
What is the error that is associated?
It's 6. And today is also this long time.
So how do I find
Or
the
tomorrow.
error?
I'm not gonna play today.
Oh, it's plus 4.
you gotta plug it back in.
But even though that's on
I know it's easy. I just don't understand the concept. I was like, what the
I just saw the team. I just like to see them.
They're not, they're just at it. It is, I would feel like, you know who soccer is?
Yeah, I know that.
He goes 4 miles faster.
I know that.
You don't know. You didn't try.
You kind of got me there.
There's your answer. What is your other?
So 10 and 10. Find his jog rate each way. Wait, uphill? Look, do it.
Wait, let me see. Who did that?
Brett.
Okay, let's see.
Mark, you're getting both. Actually, if it's not signing, actually equals 6. Oh. So that's 6. But then x plus 4.
And then since it's the downhill,
Yeah.
I'll
Mark,
show
why
my
do you like to
work.
do that?
How do you know that is up?
Gabe, quit talking across the room and do your work.
I apologize, Miss. Grab it all. Oh, you had to. Oh, okay.
You should have gotten an uphill speed of 6 miles per hour. If you did not have units, I would take off on your quiz. Downhill should have been 10 miles per hour.
Oh, this actually makes more sense.
And this would have come from you plugging into x plus 4. Okay, let's set up the next one. It is a different kind of situation. We have trains. We have a passenger train. We have a freight train. If the passenger train travels 20 miles per hour faster than the freight train, find the speed of each one. So I'm going to do the same thing. I'm going to set up a table. Distance, rate, time. And then I'm going to have a passenger train. I am going to have a freight train. Okay, so it says a passenger train travels 392 miles. So that's my distance, 392. In the same time, it takes a freight train to travel 322 miles. So 322. Now, if the passenger train travels 20 miles per hour faster than the freight train we're going to call speed x. And so for the passenger train, it goes 20 miles per hour faster. So I'm going to write this as x plus 20. Yes. So it's not 20 times as fast. It's just 20 miles per hour faster. So if they had said times as fast, then we wouldn't multiply. And then we're going to have T1 is equal to 392 over x plus 20. T2, we are going to have 322 over x plus, or just x. Huh? You understand it? Good. That's okay. Let's go in. Because these numbers are a little bit bigger, I'm going to work through this one with you. It is still a same time problem. They are happening in the same time. So that means I'm going to set them equal to each other. So I'm going to have 392 over x plus 20 is equal to 322 over x. Now, my LCD is going to be my x plus 20, which again, it's not really going to create undefined values for us that are going to give us any issues. It would just be 0 and negative 20, which wouldn't make sense anyway. So we typically, again, don't ask you to define them in these cases because we know that they're not going to make sense anyway. And hopefully when you're picking between your answers, if you saw negative 20, you would be like, that doesn't make sense, and you would cross it out anyway. So now I'm going to go in and I'm going to give an x to the numerator, x to the denominator, x plus 20 to the numerator, x plus 20 to the denominator, and they eventually get canceled out. From the denominators only, not from the numerators. And then we are going to get 392x is equal to 322x plus 6,440. Again, you will have a 4-function calculator built into your formative, your quiz. I will actually build it into your practice so you can kind of play around with it a little bit today. So any numbers where you're like, that's really big, I never would have multiplied those and been able to get it right, Don't worry about that. That is not the part that we are assessing you on. So now I'm going to go in. I'm going to subtract 322x. And that's going to be 70x is equal to 6,440. And again, you will have a calculator, so you will be able to go in and divide by 70, divide by 70. And this is going to give us x is equal to 92. The big thing that you have to be careful on with these types of problems is that you are fully answering the question. Just getting 92 is not enough. They want to know the speed of each train. So I'm going to come in and I'm going to say the freight train is going 92 miles per hour, and the passenger train, it's going to go 92 miles per hour with that additional 20 added on. So it's actually going to go 112 miles per hour. So the big thing here for word problems is mostly just double checking, did I actually answer the question, or do I just have a piece of the overall question? Okay, last one is going to kind of switch things up slightly. It's not going to be like completely something different. A river barge is traveling, it's like a boat, down a river in still water at 8 miles per hour. So that means its speed with nothing else happening is just 8 miles per hour. That is the speed of the barge. The barge travels 60 miles up the Mississippi River and 60 miles down the Mississippi River in a total of 16.5 hours. What is the average speed of the current in this section of the Mississippi River? So when we write this, when I set up the rate, it is going to be the barge speed plus minus the current, because the current is what is going to increase. It's the something extra. It's going to increase the barge speed or it's going to decrease the barge speed depending on if you're going up or down river. So I'm going to set up my table, same exact way I've been doing. Distance, rate, time. And we have similar directions. We have upriver, we have downriver. Now, upriver, you're going to go slower, and downriver, you're going to go faster. So just in the same way we talked about going uphill and downhill, the same thing happens. The Mississippi drains into the ocean and it goes faster that way. Now, with this, it does not necessarily tell us, oh, it's saying 60 miles up and 60 miles down. So I'm going to give my distance, 60, 60. The rate, here is where a lot of people will mess up. They will say x plus 8, x minus 8. But remember, the object speed is what goes first. The barge speed is the first thing we're going to write. We're going to write 8 and 8. No matter what, this barge, this boat, is going 8 miles per hour. In this, is it kilometer? No, it's miles. Miles per hour. Now, when it's going upriver, it's being slowed down because it's going against the current. So I'm going to subtract x. And then when it's going downriver, it's going faster. So I'm going to add that current speed to it. Now, normally, in the addition part, the order does not matter. But if you set this up and you have x minus 8 instead of 8 minus x, it is going to mess up your answer. So anytime you are given the speed of the object first, make sure that you are plugging it in with the object speed and then everything extra after that. And then we have T1, we have T2. I'm going to go ahead and set up my fractions. 8 minus x, 60 over 8 plus x. And this one's slightly different because they don't tell us it happened in the same amount of time. They tell us it happened in a total of 16.5 hours. So what that means is T1 plus T2 is equal to 16.5. So I'm going to fill in what I know. We know 60 over 8 minus x plus 60 over 8 plus x is equal to 16.5 over 1. Because anytime you have a whole number, you can treat it as if it is being divided by 1. What is my least common denominator? 8 minus x, 8 plus x. So every single fraction that I have has to have the same denominator. So I'm going to come in, I'm going to do 8 plus x, 8 plus x. I'm going to do 8 minus x, 8 minus x. I'm going to do 8 plus x, 8 minus x, top and bottom. Now, this is one where, again, we can go in and kind of write our undefined values, but usually, again, they're not going to give you any issues. It can't be plus or minus 8. Both of those make the denominator 0, which causes issues. So we can list them out. I don't even think on the quiz we have a spot for undefined values, so I wouldn't worry too much about them in these cases because they're usually not going to give you any problems. So now, I have my numerators only, and this is where, again, your calculator probably would be helping you a lot with just the algebra, but I'm going to help you with the algebra for now. 8 times, what is 8 times 6? 48, so 480, plus 60x, plus 480, minus 60x, equals. Now here is where I had a lot of confusion before about what do I do when I have a number and I have a binomial and a binomial. What do I multiply first? Do I distribute to everything? If I were you, I would multiply the 8 plus x and the 8 minus x first. Then I would distribute. I got this question a ton across the last couple of lessons. So this is actually going to simplify into 64 minus x squared. When I go in and I double distribute, this is going to turn into 64 minus x squared because it is a difference of squares, meaning that middle term is going to end up canceling out. And then we start combining and simplifying things. So let's see. 60x minus 60x, those cancel each other out. I'm going to get 960 is equal to, if I multiply, because I'm going to have to distribute these, 16.5 times 64, I'm going to get 1,056 minus 16.5x squared. Again, you will have a calculator. Don't freak out because you're worried about the multiplication. You will have something to help you out with that. Now, I want to kind of get these terms so that they are solvable. And normally, when you have an x squared term, I tell you to move everything to one side. I'm actually going to try to get the x terms on one side and the other term on the other. So I'm going to subtract 1056. And that's going to give me 96, negative 96, is equal to negative 16.5 x squared. And then I'm going to divide by negative 16.5. And you're going to get a decimal value from this. And so, again, you're probably most likely just going to keep this in your calculator. And we are going to end up with 5.82 is equal to x squared. Now, how do I get rid of a squared? A square root. You will have a calculator that can take a square root. So I'm going to come in and I'm going to square root the left side. I'm going to square root the right side. Now, normally, when you do this, you're going to get two answers. You're going to get plus or minus. So this would technically be plus or minus, 2.41. But does it make sense if I'm talking about the speed of a river for it to be negative? No. So you only want to take the positive speed. So this is going to be 2.41 miles per hour. This is the current speed, not the boat speed. This is the speed of the current, because this is what is being added to 8 miles per hour and subtracted from 8 miles per hour. Okay. When is your quiz over this lesson? Thursday. Is it over anything but this lesson? No, it is only this stuff. I'm going to come around. I'm going to pass out your practice.